Hello and welcome to my YouTube channel. Today in this video we are going to develop a small project, that is light controlled LED, using the Nucleo STM32F446RE Microcontroller Board, and we are going to use analog to digital converter to complete this project. Now let us talk about the programming part. We will be using the same code, almost the same code which we used in the part 2 of this series, and with very small modifications we can implement this project. So first of all, we'll be reading the analog value received at the ADC channel number 1. We completed this up to this part in the part number 2, and then we will develop a small algorithm based on which the onboard LED will be either on or off. Let us see the flowchart of this project. First of all, we will initialize the analog to digital converter that we did in the part 2, and then we will initialize the GPIO pin to which the onboard LED is connected. After reading the ADC value, we will compare that value with a threshold value that we will provide from our end. And if the ADC value is greater than the threshold, then we will make the GPIO pin or the LED off. This represents that we have enough light in the environment, and therefore we don't need the onboard LED to be on. Then if the ADC value is less than the threshold, then we will make the LED high. This will represent that in the environment we don't have sufficient light, therefore we will turn on the onboard LED. Now let us talk about the connections. We will use the Nucleo F446RE Microcontroller Board. We will use an LDR, which is light dependent resistor. With that, we will connect a 10 kilo ohm resistor in series, which will be connected to the ground. We will connect the plus 5 volt from the board to the one of the terminals of LDR. We will connect the junction of LDR and resistor to pin A1 of the microcontroller board, and the ground will be connected to the ground pin of the microcontroller board. Now let us go to the coding part. For that, we will use the STM32 CubeMX IDE. Let's open the IDE. In this, we will create a new project. Click STM32 project, and then we will have to select the microcontroller board on which we will be programming our algorithm. So let us select the board. So we will type Nucleo F446RE microcontroller board, and then click on the board and click next. Here we will have to give a name to the project. So let us give a name ADC underscore LED underscore control, and click next and finish. So do we have to initialize all the peripherals? with their default mode? No. Now we will be entering in the CubeMX perspective. We saw this in the part 2 also. CubeMX will be used to initialize the ADC and GPIO pins. And after the initialization, we will use C perspective to write the code. It's taking some time to update the software again. Anyway, so we have the CubeMX perspective. First of all, let us go to the system core. Click on system, and now we can go to the RCC. We can select crystal ceramic oscillator. Then go to pin out, clear all the pin out, and click yes to clear the pin outs. Now we have the microcontroller board. We can see all the pins have been deactivated. We have to use the ADC one. Like in the last part, or like in the second part, we will select in 1, which is input 1 from the ADC channel number 1. Now let us see the configuration. Do we have to make any changes? Again we are using 12-bit resolution. Let us go down, and here we don't have to make any other changes. Now in this project we are also going to use the GPIO. Okay, so we can go to the GPIO, and we know that the LED or the onboard LED is connected to PA5 of the microcontroller board. Click on that pin and come down and configure it to be GPIO output. Now let us give a name to this pin. So right click on the pin, enter user label, and we can give it a name LED. Now after this, we have completed the configuration or initialization in the CubeMX. We can generate the code. For that we can click save all, or we can click the gear, device configuration, tool, code generation. It is your choice to click any one of them. So now we have generated the code for our project, and like in the last part, we are going to make small changes in the code. So first of all, let me declare a variable to store the analog values. For that I can use ADC underscore val, which we have done in the last part also. Then we will come to the while loop. Okay, go down. This is the while loop, and here you can see user code begin. So keep the code in this region. Otherwise, if we make any changes in the CubeMX, then this code or the user code will be deleted. So always keep the user code within the user code section. Now let us start writing the code. Hall underscore ADC control space, and we can start the ADC. We can provide the handler ADC1. Now after this we can go for hall underscore ADC underscore polling, because that is what we did in the last class, last lecture or last presentation. We can change the handler. We can give 5 milliseconds timeout, semicolon. Now let us read the value of ADC and store it in the variable that we declared. Okay, that is equal to all underscore ADC get get value, and then we pass the handler and done. Once we read the value, we can stop the ADC all underscore ADC underscore stop, and we can pass the handler. So this is what we did in the part 2. Up to this we did, or we completed up to this code in the part 2. Now we have to develop our, or we have to put our algorithm to control the LED. So we can use if ADC val is greater than or equal to any value, which you must first check the values which you are getting from the junction of LDR and the resistor, and based on that you can make a decision to put a value. Instead of 2048 you can use any other value. I am using 2048 because it is in the mid of 4096 and 0, so it is half of 4096, which is the maximum value for the ADC. And then we can use hall underscore GPIO, and we can use write. So here we have to provide the port name, so LED port, and then we have to provide the pin name, so we can put LED pin, and here we have to provide the state. What should be the state? Okay, so to know about these functions, you can just right click on this function and go to the open declaration. Let me just select this function and click open declaration, and you will reach through the all underscore gpio.c file, where you can see what is the definition of this function and what this function will do for you. Okay, so here you can see there are 3 parameters in the function. Okay, GPIO X, which is the port, GPIO pin, which is the pin, and then the state in which you want to put this pin. So here for the third parameter we can choose 2 variables, GPIO pin reset or GPIO pin set. So we have to reset it, so copy this and come back, and instead of pin state you paste the reset value. Now this is for the condition when the ADC value is greater than 2048. Else we can write all GPIO set. So I will just copy this code and paste it here. Instead of reset, I will just GPIO underscore pin underscore set. Okay, so this is the final code, and we don't have to make any other changes. Save the code, and now we can start or debug the code. So let us check if there is any error and upload the code on the microcontroller board. So we can see there is no error, no warning, and we will enter into the debug perspective. Okay, so we are going to enter in the debug perspective. Okay, waiting for the debugger connection. And here we can see we have entered into the debug perspective. We can go to the live expression to see the value of the variable ADC val. Let me open the camera. Here we can see the onboard LED right now is off, and we can see the connection. Now let me run the code, and we can observe that the ADC val is getting 4095, which is greater than 2048. Therefore the onboard LED is off, which shows that in the environment we have sufficient light. Let me bring my finger on top of the LDR, and you can see the green light is on, off, on. So based on the environment or the light in the environment, we can turn on or off the LED. And we can see on the ADC val, when the value of ADC val is less than 2048, the onboard LED is on, and whenever the ADC val is greater than 2048, the onboard LED is off. So you can develop similar projects on the basis of which you can read the multiple ADCs, and based on the readings from the multiple ADCs, you can make decisions to achieve some goals. With this, I would like to end the presentation. If you have any doubts or suggestions, please share your doubts, suggestions and comments in the comment section. If you have not subscribed the channel, then I would request you to please subscribe the channel and press the bell icon so that you will get the notification as soon as I upload a new video. Thank you and have a nice day.